Good morning, colleagues. This is Ric-Hansen. One of the requirements is the computing of regular layouts, and this was not done in the first video, so I'm picking up on it now because it's a slightly more complicated process. Now, this is divided into import from CAD, georeferencing of the layout, resolve topology issues and incorrect computing, remove duplicate lines and delete overlapping lines, generate points at intersecting lines, naming of points and block corners, and then creating polygons and allocating plot numbers, and then generating consistencies. These steps are really given as a guideline, and one does not have to follow them exactly, but it really depends on the nature of the particular layout. You'll remember that in the previous video, we dealt with the situation where you import a polygon shape file. So your starting data set is the polygon data set, and then we create lines for the directions and distances and coordinates. This process is different in that our starting point is that we start with a line data set. The line data set is derived from a CAD file. And so the idea is that we need to import the CAD file and then create points and polygons. To demonstrate this process, I have started with a diagram which I got from a locality sketch. So I've captured that diagram. You can see it's Earth 856 here. So that diagram has been captured and it's now in an Informate project as Earth or plot 856. I have imported a CAD layout and I've chosen a rather difficult one. There's quite a few issues with this particular layout. It will assist us to go through the process of how we rectify the layout to make it correct. The first thing that we need to check is that the layout is georeferenced. And if we have a look at the locality sketch here, we will see that the y value of coordinate A is minus 54,998.73. Now, if we go into the corresponding coordinate in the layout, in the CAD layout, we can see it's 51,361. So clearly, the layout has not been georeferenced. So it has to be modified in some way in order to georeference it. Now, there are three possibilities here. The first one is that it needs to be rotated, and it looks to me very much like it doesn't need to be rotated because if you look at the plot in the CAD here and you look at the locality sketch, it looks like it hasn't been rotated in CAD, so it has the right orientation. Secondly, we could measure the distance in CAD across the base of this plot, which I've already done. I'm not going to do it again, but I have measured it, and it looks like the scale of the CAD is correct. But the last issue is that it seems to have been shifted, so we need to deal with the shift. There are many ways of doing this. You could correct the georeferencing in CAD if it's easier to do it that way, or you could bring it into Informate and correct it in Informate, and that's the way we're going to do it this time. So I'm going to close the CAD window, and I'm going to close the locality sketch or the diagram, and then we're going to proceed with the process of georeferencing that image. So we start by going to File and Import, and we choose CAD Drawing, and we then choose the correct CAD drawing, which sits here, and it's called Ramatlabama. Now we need to know which components of this CAD layout to bring in, because we don't want to bring in information that'll just be noise in our Informate project. So we need to bring in meaningful information. So in this little CAD viewer here, we are able to turn off all the layers and then turn on specific layers that we may be interested in bringing in. So we're going to bring in database lines. We're going to bring in database polygons. This is a bit of a misnomer because they're actually not polygons. It would be nice if they were, but they're actually lines. The database text we're not going to bring in. The default layer, we're not going to bring that in because that's just shading. And then we'll bring in earth lines because that adds a few more lines. And that's basically what we're going to import. We're going to choose fields here so that we map all the source fields into the line table, because there may be some information that may assist us there. And then we import it. Now this process happens for points, lines, and polygons. So we do it 3 times. Unfortunately, there are no polygons in this particular CAD layout. CAD doesn't deal very well with polygons, so in this particular case, there are no polygons. If we zoom all to fit, we can see that we have our layout on the left and our project on the right. In order to georeference this layout, I'm going to use the geometric tools. So I've loaded the geometric tools, and I'm going to use this option here, Shift Selected Points. Before I do that, I'm going to select all the coordinates that are part of this layout, and then I'm then going to move it incrementally closer to the diagram on the right-hand side here, with the plot on the right-hand side. So I'm going to use Shift Selected Points. Initially, I'm going to just use Click Point, because I just want to click somewhere close to the figure. So I'm going to click roughly here, which is the point, the location of that polygon, and I'm just going to drag it across, say, to here. Well, let's make it here. And then I'm going to hit Calculate. So you can see that it moves it all closer to the correct position, just using a click point. Okay, so these coordinates are still selected. So what I'm going to do now is I'm going to revert back to the active point table, and I'm going to select this point here, and I'm going to select that point there, which is the corresponding point. I think I've got to do that again. Let me just do that again. So the first point is this one. Sorry, I'm going to clear that. I'm going to go from this point to this point. So you can see what it's going to do. It's going to drag this layout up and superimpose it in the right position. So if I hit Calculate, it should do that. Yeah, so it's done that. I'm going to zoom all to fit. And just a bit of explanation about this process of transforming the one data set to fit another one. If you use more than one point to do the transformation, okay, let's go back one step. I just used a shift, but you could also use a transformation, which is this tool here, where you could select more than one coordinate as the source and the destination of your transformation. But there you could end up with problems. It's most likely that in the course of computing the CAD layout, the regular plots were all done with rounded distances and directions. So you may find that all your plots, say, were 20 meters by 40 meters. Now, if you choose 2 or more points to do your transformation, you may find that your source points and destination points do not match exactly, and you may introduce residuals, which means that when you do the transformation, your distances, which were 20 and 40 meters, may now be 20.12 and 40.68, for example, which will cause you all kinds of problems, because now also your directions and distance will not be rounded numbers, and it may distort your layout, and maybe that is not what you intended in the first place. So the CAD layout has been imported and georeferenced, and it's now necessary to resolve topology issues and incorrect computing. So let's see what we've ended up with here. The first thing that we can see is that we've got points, but they don't have any names other than these first 4 points here that were captured initially. We have lines, which came in from the line CAD layout, and we have no polygons, apart from this one that was imported, that was captured initially. So the objective of this process now is to create polygons. And in order to do that, we need to make sure that the lines are all correct. So we're going to have a look at this layout and try to identify issues. Before we do that, we're just going to create point names for all the coordinates. So I have selected all the coordinates other than the first 4, and I'm going to go to Field Tools, Calculate Unique Value, Name, and I'll just make them 1, 2, 3, 4, 5. As you can see now, all the points have got names, have got numbers, and just a point of note here, we've added an option here to say max value, and the reason we've done this is because it was identified that if you have, say, a prefix of A, and then you just allow it to calculate points to be A1, A2, A3, eventually your point names become quite long. So this max value is the maximum increment that you will have after your prefix. So for example, when it gets to A99, it will stop, and then it will go to B1, B2, B3, B4, like that. In the geometric toolbar, we have a facility that assists us to check for the way the layout was computed and how accurately it was computed. So if we choose this option here, which tests lines, and we select this line here, for example, and then we click all. Let's do that again. We select this line, and then we click all. And you'll see that all lines that are parallel with the one that was selected will be shown in blue, and all those that are in red will not be parallel to that particular line. We can also check the perpendicular lines by clicking the perpendicular option and then clicking all, and we can see that all of these uprights here are parallel, including these over here, but these other ones are not parallel. The next facility that we have to check the quality of the layout is this option here, which draws node angles. Now we can see here that even though we have a line endpoint for this line here, what this is telling us is that this line over here it goes all the way from that point to that point. In other words, it goes all the way from 59 to 58. And that is a problem from the point of view of creating polygons, because all these lines need to go just from for example, 58 to 21, but we've introduced a tool that will assist us to fix that. We can also see that there's a bit of incorrect computing here, and some work needs to be done to clean this up. So if we use that same tool and we choose parallel lines, we select this line here, and then we click select all, we can see that one of these two lines here is not parallel. So this has to be cleaned up. That the incorrect point here needs to be removed. So for example, what you'd have to do is you'd have to select the point on the top here. So for example, we would select that point and we would delete it. Now, it's quite a lot of work, and it takes a little bit of time, but it's the only way to get the correct result. We have a similar situation here where there are duplicate lines and there are also overshoots. So all of these things need to be corrected. And what I have done is I've put in a background feature with the correct lines where they should be. And if we zoom in here a little bit more, we can see where the correct line is and where the incorrect lines are. So for example, here we have an overshoot at 26. So this line coming up here needs to be cut off at that point, and 26 needs to move down. And that's best done with the intersect routine, this one here from the survey toolbars. So the next step is to remove duplicate lines and delete overlapping lines, and then to generate points at intersecting lines. This is necessary as during the course of creating the layout in CAD, there may be duplicate lines created. Okay, so the first thing that I want to show you is if we zoom in over here and we select these lines at the end of this block, it looks like there are only two lines here, but if you have a look here, if we select them using a polygon, you will see there are actually four lines there. So there could well be overlapping lines. So what we need to do is we need to go to Utilities, remove duplicate lines. Now this is a fairly quick process. And then we go back and we go to Utilities, delete overlapping lines. Okay, so that process is now done. The next process that we need to do is to go to Utilities and generate points from intersecting lines. And you see it goes all the way through the project and generates points at each of the line intersections if the point is not already there. Okay, that process is finished. So let's see what we have at the end of this process. If we zoom in over here and we select these lines that we selected previously, we should only have two lines selected, which is correct. So there are, in fact, only two lines here, over there and over there. So basically what this process does, it not only checks to see that there's a coordinate at each line intersect, it also breaks the lines up so that, for example, this line here goes from this point to 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 there to there to there to there to there. So it breaks up the line into its individual components. So this, in effect, facilitates the creation of the polygons automatically. The next step is to give names to the points and to the block corners. Okay, so the lines have all been sorted out. So the next thing that we need to do is to finalize the names of the points. Now, I have already given the points names or numbers from 1 upwards, but you probably want to name the blocks correctly, as is the convention. So if we zoom into a specific area and we then turn the point names on, in fact, this has already been done. I've already done it on this project. It was not for the whole thing, but I've done it on the project for sections of it. So let me try and find a block that hasn't been done. It looks like they've all been done. So what I'm going to do is, just as an exercise, I'm going to do this little section here, just to show you the process. So you use the geometric toolbar and you use this option here. Sorry, not that one, this one here. And we're going to call this point, we'll call it Z1. So when we select this point and then calculate it, it becomes Z1. And then it automatically increments to Z2. So we go there. And then we go there. And then we go there. So that's the process that you use going around the block, so that all the points have the correct numbers or names. The next step is to create the polygons, and as you can see here, there are no polygons at the moment. So what we do is we select all the lines, and then we use this tool here to generate polygons from lines. That process seems to have come to an end, and as we can see here, we've created 146 polygons. So just to confirm then, we can see that we have 146 polygons that have been created. Now let's also see what we've got here. I'm going to unselect all the lines. I'm going to open the polygon table and I'm going to select all the polygons. Now you can see that there are a couple of polygons which for some reason have not been completed correctly. So what one would have to do is just to go in and correct those, which is the process I'm going to do right now. The reason why it's done this is because this is a particularly difficult area and there are quite a few issues with it. So in a normal regular layout, you shouldn't have this number of issues. I noticed that the previous video terminated too soon, and it didn't really show the polygons that were not correctly created, but there were about 10 or so polygons that were incorrectly created. So I have deleted 2 or 3 polygons, and I've also recreated about 12 or 13 polygons. So the end result now is that we have a layout that looks like this, with all the polygons being formed correctly. So the next step is to allocate plot numbers. And to do that, we're going to zoom into this block here. And this is block A. So I imagine that's the one that should have the lowest plot number. So I'm going to use this tool over here. And I'm going to give it the plot number 501. And then I'm going to click the plot. So what you do is you just work your way around here and click all these plots, and it will put the plot numbers in there for you. Now, I'm not going to do them while this video is running because it'll take quite a while to complete all of them, but that is the process that you do. So you work block by block and you allocate all the plot numbers until you've done the whole project. So there are only two things that we need to do now, and the first one is that we need to select the line data set, or select all the lines in the line data set. Then we go to utilities and we choose directions and distances, and we allocate directions and distances to all the lines. Once that's been done, the last thing that we need to do is to auto-generate consistencies using the cadastral toolbar. Before we do that, we must just make sure that the option here, enable consistency output to calculation windows, is set on, and then we use the auto-generate consistencies, output all, and that will send all the consistencies to the, sorry, we have to select all the consistency, all the polygons first. My apologies. So we go to here, we select all of them, and then we go back to the auto-generate consistencies, and we then create all the consistencies, and that's basically it. It's done. If we go to the calculation results window, we can see that all the consistencies have been output. That then is the process of computing a town planning layout, and obviously the quality of the input layout depends largely on, or the effort involved depends largely on the quality of the input layout. So the remaining two issues that were identified at the recent training are the A3 diagram for main figures, and then a coordinate comparison for a situation where an existing plot is resurveyed, and the coordinate comparison will identify whether the original survey is adopted or rejected. I will get back to you regarding the due dates for these changes. Thank you. Thank you very much for watching this video. If there are any questions or queries, or you need any assistance, please do not hesitate to contact me, either at the South African code 08244230777 or at patrick@compuplot.com. Thank you very much.